So, good morning, everyone. Thank you all for coming in this number to this early morning lecture session. And today, if we can start. Yeah, okay, we can start. Today, I would like to talk to you about my experience trying to integrate Java and Groovy within existing and new Java web applications. The talk is going to be mostly about integration in Groovy with Spring. Sorry, AGB guys, I haven't had the time to try this out with AGB, but with Spring we've tried it, and I think we can do this even with AGB. If anyone wants to try, go ahead. So today we're going to be talking about simple differences between Java language and Groovy language, integrating Spring with Groovy, working with entire Spring ecosystem in Groovy, and as well testing with Groovy, and of course more testing. Because we all love testing, right? So, first things first, what's Groovy? Groovy is a dynamic language of the JVM, which is fully compatible with all existing Java libraries. It's inspired by other languages like Python, Smalltalk, and Ruby. So, why Groovy? Because it makes Java code easier to read. We're writing less code, and by writing less code, we can make our thoughts easier to understand in our code, better than just trying to write a lot of code. It's interoperable with all the Java libraries we know, and Groovy libraries can be used in the Java ecosystem. It compiles into Java bytecode. It's not trying to hack JVM as much as other JVM languages. It's a lot less verbose. There is a lot less boilerplate code required to get same results as in Java. And types are optional but checked. So some differences between Java, between Java and Groovy. Groovy has a lot of default imports, so you don't have to import everything. Semicolons are optional. You can write them down. You can write semicolons to terminate the lines, the statements, but that's considered not a good Groovy programming. Return keyword is also optional, so the last executed statement is going to be the return value of the method. Equality operator from Java, that's a big difference for all Java developers, means actually equals call. It does not make equality by reference. It makes equality by the equals method. Getters and setters in Groovy, you don't really have to write them. They're there automatically whenever you say that there is a property. A public accessor is by default. So Groovy takes a lot of defaults for you. You don't have to write everything down. Public is default. Getters and setters are there on their own. And Groovy truth is not something like Java truth. Think more like C. Null is false, 0 is false, empty collection is false, empty string is false. Everything else is true. And also, parentheses are optional, but we do like to write them because not writing them sometimes can lead to confusion. Places where we don't write parentheses are some kind of print line statements if you're writing console application, log statements, because then we just say log, and we quote our string. And Groovy also introduces a lot of time savers for Java developers. Some of them are iteration methods inspired by Ruby and Python, like each, collect, find all, find one. Also, we have a lot of operators. And null save dereference is probably something most of us in Java have a lot of problems with. We have to always check for null safety before we go to the reference another depth in depth on our object tree. So null save dereference, real-time saver lets us write less code. There's also an Elvis operator, which is a ternary operator shorthand. So if the Boolean value in the test is true, return that value. Otherwise, return something we set as a default value after the Elvis operator. A spread operator lets us access a property or a method on every object in a collection, whatever that collection might be. So it's a pretty good time saver if we have to extract just one property for a collection of objects. Working with regular expressions in Groovy is much nicer, much easier than working in Java. There is a syntax for writing regular expressions, the slash syntax, where you have two slashes, one starting the regular expression and the one ending it. There are a lot of operators for matching and checking if there is a match in regular expression. Plus also, it's a lot easier to index anything in Groovy than in Java, especially when working with collections or, for example, strings. A subscript operator works same like the subscript operator in Java on arrays, but in Groovy it works on array lists, on strings, on practically any kind of a collection. So any kind of a collection, give me the first element is this. We'll have to really write a lot less code to get some things done. So why we want to use Groovy in our web apps? For production code. I'm not here talking about testing, I'm talking about production code. We get to express our thoughts, our algorithms, our business logic before we have to write a lot of syntax to get it done. So we are expressing our thoughts more and writing code less. It's relatively easy to learn. If you know Java, you can use your existing Java code, just compile it with a Groovy compiler, and in around 90% cases, it's going to work out of the box. Less code means fewer errors. We don't have to write so many statements in order to get certain thing done. So we're less error prone, even though thanks to our IDEs, we get a lot of checking. And less code in production means more code in tests. And we all like that one. Another question that's probably going to come up is why not use Grails? Grails doesn't really like integrating with existing Java applications. We have to rewrite everything into an entire new ecosystem. So if we have a running Java application in production and we want to use Grails, we have to rewrite everything. Rewriting takes time. You have to learn the entire new ecosystem, which can sometimes be a problem to developers and companies. And maybe we would like to take small steps. We would like to learn a new language before we learn a whole new ecosystem. So we can use Groovy in our existing Java applications and learn the language before we go to learn the entire ecosystem. We're being forced, maybe. Maybe somebody doesn't allow us to use Grails. Maybe we can get by with using Groovy, perhaps just in tests, instead of going all in with Grails. I'm going to talk a little bit about integration here with existing Java tools. Mainly, I'm going to focus on Ant, Maven, and Gradle. For Ant, there is a native Groovy compiler, which integrates well into unscripting. It supports any Groovy version. This is not true for each of the integrations. It uses stubs for joint compiling between Java and Groovy. That can lead to some compatibility issues if you have a lot of intermixing code intermixing calls between Java and Groovy. But usually, I haven't found problems with that one. But it still uses Ant. I don't like Ant anymore. Next thing, we have Maven. For Maven, we have two options, better to say three options. We can use just Ant task in Maven. We can use gmaven Plus, which supports, again, any version of Groovy. Again, it uses stubs for joint compilation, so there could be problems in compiling. The problem is it's not a native Maven compiler plugin, so integration is a bit tricky. And there is a pretty poor integration with IDEs, especially Eclipse. Eclipse doesn't have native plugins for knowing that this project is compiled with gmaven Plus. The other option, if we really like Eclipse and we want to work with Eclipse and we want to have everything out of the box, it's a Groovy Eclipse compiler, which has one problem for me, and that is that it completely replaces Java compiler. So everything gets compiled, everything gets compiled by Groovy compiler, and that's Groovy Eclipse compiler. It's a native Maven plugin, so it works well with Maven. It works well with all IDEs. The problem also is it restricts a version of Groovy we can use. Groovy Eclipse compiler, one version of Groovy. Usually it lags behind a bit from regular Groovy compilers, so you might have to check which version of Groovy you should be running on. And there is no support for Invoke Dynamic or Groovy Indie in Eclipse Groovy compiler. Also Gradle, for all of you who are advanced and coming up in front of the age. It's using Groovy Ant task, so it has the same benefits and same failings as the Groovy Ant compiler. And since Gradle has a pretty good integration in all 8 IDEs, integration should not be a problem. So let's talk about time saving in production code. For example, we have this kind of a model. I don't know how good you can see. So we have 4 classes which are nested in a very ugly way. And we cannot change this. This has been God-given to us by our beloved DBD team. We get, from a service, we get a list of these objects, and anything can be null. We don't have any null safety here. So whatever we dereference here, we can get nulls. And here are some requirements. Some manager said, we want you to count the all-important old beans with this important Boolean value to true, which can be also null. And we want you to sort us give us the top 3 sorted by this big decimal monetary value, descending. And let's go a bit into Java code. So this is not the best thing, probably. You can write this nicer, but if you look at this if, which checks for a null safety, it's ugly as hell. You can probably do this better with using some libraries, but this is plain Java. And also, first 3 elements, not the nicest code I wrote ever, but we usually write this sometimes because we cannot change the way we get our data from. There are situations when we cannot change how do we get our data from. So we have a sort using a comparator, and we have an iteration where we read the name of the first 3 elements, just to make things more interesting. Now let's get to Groovy. All that, 2 slides in this. We're adding, I'm using Spring controllers here as examples, so we're adding an attribute into Spring model, count of the list where all this equals true. This is an example of null safe dereference with Groovy. So the first time this statement hits a null, it's going to return a null. On the first element, it hits a null. So if it hits a null over here, on the first nested, it's going to return null, and null is false in Groovy, so it's not going to be counted. Other thing is, we want to sort and get the top 3 elements. We're using the Groovy method sort on a collection. We're sorting using a spaceship operator, which is another operator added in Groovy. Yeah, it's actually called a spaceship operator. It's actually called to the compare method in Java, just to make it a more visual, less code. So we're trying to get more visual to see what's going on. And we're using a substring index operator with a range in it. So we're saying all the numbers from 0 to 2, give me those indexes from this list. And that's it. I would say this is a pretty good time saver and a lot less code. Now I would like to go into testing with Groovy and Java. JUnit is good. Why not? We all use it. There's still a lot of boilerplate code we have to write in JUnit to get our unit tests running. And we need a lot of libraries to get things looking nicer. So why Groovy? Groovy has a much more powerful assert statement than Java. And I would say even than some of the Java libraries we can use for assertions. Groovy is a fully dynamic language, so if we really want to, we can easily replace method calls to existing objects without having to use Mockito's abilities to, for example, replace a call to the method on a real object. And also because it's a lot less verbose language, we can write a lot less code to get our unit tests done. So here's a bit of example for unit test that tests that same controller code we saw before. And in order to make it fit on this slide, I omitted a lot of imports. There's a static imports to Mockito and fast assertions over here. So just to shorten up the code and make it a bit more readable. There is omitted class instantiation and preparation of the data and mocks here. And this is the minimal test we can write for that controller. So it tests that we get correct amount of data, correct count, and that we get the top 3 elements ordered in really exact way, and only the top 3 elements. Same test the Groovy way. This, I omitted just the data preparation statement. You can find all the source code on GitHub. On the end of the presentation, I'm going to give you the link. So over here, this is the complete unit test, which tests everything the same way the Java one does. Only thing, but I've just omitted the preparation of data. Here, I'm using a nice dynamic value virtue of Groovy, where I can instantiate a map of closures and just say that that map of closures should present itself as the class model. This is Org Spring Framework Web, I believe, model. We all know how to use it in controllers. So I just say I want method add attribute to have these properties, these parameters, attribute in value, and I want it to behave as a model to the code. So when the controller calls add attribute method on the model, I passed it on. It's going to actually add the values over here. And now, the star of this presentation, I would say, the data-driven tests. If you've written Java unit tests and Java data-driven tests with JUnit 4, we all know the parameterized JUnit runner. But what about if you want to write a data-driven test with a parameterized JUnit runner, and we want to load the Spring context? Or we want to load Mockito to automatically mock stuff for us. There is no out-of-the-box solution for that. There is no parameterized JUnit 4 Spring runner. So we all end up writing some boilerplate code of ours to get that context loaded, to get things running a bit parameterized, and it's not really the nicest thing. So I even haven't bothered writing a parameterized JUnit runner for this presentation. I believe a lot of us wrote one eventually. And when you get to a lot of data we are testing about, it doesn't get, it's not readable, it gets complicated, it has a lot of boilerplate. So let's welcome Spock. Spock is a testing framework based on specifications mostly. It brings new meaning to data-driven. Instead of just preparing the test, we just describe the test. So we're mostly doing describing the test, describing the expected behavior, and letting our framework do the thing. It's written in Groovy, so it does require Groovy in your project in the testing phase. It's inspired by JUnit, JMock, and even by RSpec from Ruby World, and it's compatible with JUnit. So here's an example of the Spring specification, Spring Spock specification. So I'm extending a specification. I'm loading some kind of a Spring context, although I don't really need it around here, but it does load a whole Spring context in it based on this XML configuration. It can be Java as well. And here's the test. We have the test split up in several sections. We have certain things that are given to us, which is an initialization of the test. We have certain things that we expect. So we expect this service to be auto-wired by Spring to us. We test for something in a certain way. So we expect that the average of the values in this model is a certain value. And then we have the where part. This is the part you all recognize from the parameterized JUnit runner, for example. We say parameters. Each parameter gets automatically mapped over here in the name of the method. It also gets mapped, where it is, here to the, where is each? Given values, here. Given values.collect. So I'm iterating over this part over here and creating the models which I'm passing to the my service which does the average. Big deal. And here's the expected part, what we're expecting for. So I'm running a bit out of time now, and I would like to come to a close. This here is the URL to the sample. The presentations, the Maven code, the Java code, and the web code are on GitHub. And I would like to ask you, are there any questions? Go ahead.
Not a question, but a comment.
Yes?
When you said that Spock is inspired by RSpec, such and that,
Yeah.
I forgot actually one thing.
Go ahead.
Also, Star Trek.
Of course, yeah. I'm sorry, I apologize to everyone. Yeah, Spock is inspired by Star Trek and by logic.
So everyone who asks a question gets this free cup.
I have one question for
Okay.
the whole room, if somebody wants. I was expecting a question, and it did not appear. So be honest to yourselves, and I want to call for a show of hands, because I know that people are going to be thinking, why not use Java 8 in all this? Java 8 brings a lot new stuff to the Java language, to the syntax, new methods, easier iteration, and so on. How many of you know of a production Java web application which is currently running Java 5 or older? Can you please raise your hands? Okay, Java 6 or older? Okay, so Groovy is compatible with Java 5 or higher. So if you have a Java 5 application running in production, you can have all of this right now. No need to migration to Java 8 or 7. Thank you.